Good morning, good afternoon, and good evening to all of our visitors from around the world. We're back at the Responsible AI Summit Day 3, and we're kicking off with our first speaker, Honey Yadav, who's on stage from India. And where it is just as cold today, we decided backstage, as it is in Spain, that's also experiencing a cold front. But I think that your presentation will quickly warm us up to some really interesting thoughts. I'll leave the stage to you, Honey. Thank you so much for joining us. I'll let you introduce yourself.
Thank you so much, Clara. And good morning, good evening, and good afternoon to all. My name is Hani Yadav. Let's have a quick discussion for today's topic. I will be presenting on privacy-enabled explainable AI. And a little bit about myself is that from last 4 to 5 years, I've been researching on AI capabilities and how specifically organizations are looking forward to prep themselves developing AI products. And in my journey of research, I have been, I think, engaged with 55 to 60 organizations that, how they perceive and how their top management, specifically the CEOs, the CTOs, that how they perceive AI as a technology and how much utility are they expecting from this technology, because it's a huge it's a costly technology at present in India, and we are seeing a lot of fuzz around and hype around this technology, and a lot of adoption is happening around all sectors, be it education, be it lifestyle, be it grocery, everywhere. Apart from that, I was engaged in Bills and Melinda Foundation project, which was meanwhile a COVID, and I was also a part of National COVID-19 strategy, a vaccine hesitant strategy, where we leverage social media platforms and how we can actually do communication decimation using social media platforms. And this is about myself. Apart from that, I've been engaged in several projects where specifically I have diverted my career into explainable AI and responsible AI arms, because meanwhile, I was researching on the journey of consumer analytics and AI systems and all these development of these systems. I realized that how important it is to actually grab on this area as well, because when I was actually into customer analytics, then we realized that the importance of explainability in from those aspects. So today we will be discussing with few of my personal examples and few of the examples that I've fetched from some pioneer research studies as well. So I'll be quick in presenting my screen so that we can start learning together. I hope that my screen is visible to all.
I will just confirm it for you here. It's not visible yet, so we're just waiting a moment for it to. There we
Yeah.
come. It's coming now. Perfect. All right. Thank you, Honey. It's
Okay.
ready to go.
Thank you. Thank you so much. So today we are going to discuss about privacy-aware explainable AI and ensuring responsible transparency in AI systems. So a little bit about myself that I've already, elaborated and my research experience and all my background. All of my projects could be found on my LinkedIn page. I'm pretty active on LinkedIn. We can exchange ideas as well if you have some of my feedback and some of the research ideas. The topic interests me more regarding privacy aware explainability and responsibility and transparency. And these three pillars, if you talk about and if you research about responsible AI, we have a pillar known as security, we have a pillar known as transparency, we have a pillar known as bias, we have a pillar known as, interpretability. And meanwhile, we all talk about that how each pillar could actually, actually be leveraged into AI system. I feel that explainability is what is at a pivotal and what actually lies into the central form of all these things that we are discussing about, because there are some external factors and dimensions that we have where we discuss that regulations and we discuss sustainability into responsible AI. But still, if we talk about privacy, which is highly correlated with security, which is highly correlated that how fair you are designing your AI systems, which is highly correlated that how transparent your systems are, how interpretable your models are, how explainable your decisions are. And on those basis, quickly, I have curated, a list of few concepts that we will discuss today. We'll start our discussion where we talk about that how explainability leveraged into decision making and how it plays a very significant role when organization take decisions on the predictions of these AI models. Then we will move forward toward explainable AI and what is the role of explainability into a responsible AI development, and how important it is to actually for us to understand that how explainability have both the arms into privacy, security, fairness, biases, and how it plays a central role. Also, we'll delve in somewhere about privacy dilemma, that always there is a trade-off between accuracy and I'll not grab the fun, but we'll discuss that what is a dilemma that is faced by most of the people who are researching into AI technology or who are actually implementing these systems. We'll discuss the clarity compromises that happens when we talk about privacy. We talk about what are the challenges that we are facing in AI development, and finally, we'll have a quick takeaways that I really want from today's presentation, that we should be discussing into our research committee, and we should actually come up with new ideas. And to begin with the very first aspect of explainability is how explainability is leveraged when we do decision making. And there is a very famous aspect of decision making which is known as bounded rationality, which was given by Herbert Simon. And he gave this concept of bounded rationality, explaining that how decision making in organizations is not actually independent, and it's not actually totally reliable on rational predictions and all the numbers and all the prediction of models that is happening around. Rather, decision making in an organization is also very intrinsic and very affected by the whole overall objective of the organizations, also the individual experiential learning that has been into that particular domain. So when we talk about explainability, it actually gives that more trustable decision making when we actually design AI systems. So for example, if we talk about in a real case scenario, when we do some analysis, and I do teach a lot of customer analytical models, and we do a lot of churn predictions, we do a lot of loan defect predictions, we do a lot of customer loyalty predictions, customer lifetime value predictions, and all these predictions, if we just go on the face value of these predictions, and when we decide and we try to make a decision on the face value, saying that okay, this is a group or this is a cohort of customers that are going to churn from my service or product, and when there is no inherent rationale behind this prediction, when the model is giving you this prediction on what features actually the model is basing this prediction on, then it becomes really difficult for the manager or for any kind of decision making person to take the right decisions. Rather, explainability fosters much more trustable decisions and much more applicable decisions and much more empowered decisions. Because when we talk about that, okay, this is a prediction that we are getting from a model, and then this is a rationale behind, and this is the rationale behind, these are the features that are responsible, and these are the features that the model is actually inheriting much more significantly, and that is why the model is giving you a particular prediction, then the decision making becomes much more applicable. And we have seen numerous examples. And many of us discuss explainability very much important into healthcare sector, because we understand that the patients and the prediction that we are doing on patients' data that require a reasonability behind any kind of prediction. But at the same point of time, when we see a lot of application of explainability, we find every sector is actually applying explainability. Rather, we talk about a very famous example that we have is of LinkedIn, when they were actually researching about that why their customers are churning and what are the potential reason behind their churn customers. And when their model and their prediction was happening, they wanted to understand the inherent features why the model was doing a particular prediction, and for from that features they wanted to understand that how they can strategically do some kind of interventions, so that they do not have to just ignore, or they do not have to just invest into doing some kind of retention programs for their churn customers. Rather, they also try to understand why behind all this, why the customer is actually churning. And the question of why can only be answered with using explainability. Another example we have is from Essential Labs, where we demonstrated, a common loan application, and not even the Essential Labs. All the banks, all the insurance, all the fintech, whenever a customer goes to a insurance, or whenever a customer go with loan application, it is the right of a customer that you provide intrinsic explanation that why the loan is getting rejected. It is hardly it is hardly advisable for an organization to actually just foresee a customer, whether the model is showing a particular customer is a potential default, or the particular customer is an appropriate profile for the loan application, whether the loan should be approved or the loan should not be approved. Rather, it's the responsibility of the organization as well to provide a rationale that why a particular loan application is not getting approved. And that's where you also provide counterfactual explanations. There are a lot of methods and techniques, although I still feel that this area is very nascent in terms of researching. Not a lot of explainable AI libraries and tools are available to be experimenting with, but to the available extent and whatever we have, we can provide very much in-depth explanations that why a particular loan application is getting rejected for a particular customer, and what are the strategies that could be actually leveraged by those customers so that they can actually get their loan approved. So these kind of explainable AI decision making not only create a environment of trust, also it keeps in check, it keeps that human AI interaction, human AI feedback into the model. And that's a very too particular responsible AI dimension that we discuss about. Next, when we talk about that, responsible AI development, one aspect of responsibility which is very much discussed is ethics, biases, security, privacy, transparency, interpretability. All these six dimensions I feel are highly correlated to each other. So if we talk about explainability, then definitely the fairness and biases will come into the picture. And I will share one experience. I was just in discussion with, a prominent leader, an industry leader. He is a CEO of a very successful organization, and I was discussing that whether the idea of responsible AI, how much feasible it is actually to build unbiased systems and unbiased outcomes from these prediction model. And he said that you are trying to imagine a ethical AI model, but you are not trying to understand that the data which is getting fed into these AI models are already biased, and the biased data is coming from us only. So the problem is not that how much particular methodologies you can apply when you are building a highly complex algorithm for your model prediction, but the problem also lies with the fact that how you holistically design your frameworks when you decide a business process automation, that what is the aspect of your business that you are trying to automate, and how much responsible AI frameworks and how much holistically you are trying to put all these pillars intact into those developments. So, for example, if we talk about biases, that how much efforts have we given to the data curation, checking the data statistically, checking that whether the data has no more class imbalance problems. All these practices actually begin from very first step of actually deciding, that okay, we are going to build a model that is going to automate this particular aspect of our business. So it is very from the start, and it is very it depends on how holistically you can design your protocols. Also, other aspect, when we talk about external dimensions, when we say regulations, when we say sustainability, definitely those dimensions are external as other dimension. But when we talk about when we talk about core aspects of responsible AI, be it security, privacy, biases, and transparency and interpretability, we also need to decide that are we looking for explainability or are we looking for interpretation? Now, most of us do not understand that there is a huge difference between interpretation and explainability. So, for example, if I want to design a deep neural network and I have a problem statement in my mind, and I'm pretty confident that I will go with the deep neural networks to actually solve this problem. Now, my inherent my inherent interpretation is already based on the fact that I'm going with a very complex deep neural networks. Now, my expectation of explanation from that kind of complex algorithm has to be understood from that point of view, that my model is not interpretable. So interpretation is very dependent on what kind of model you are choosing to solve your problem. It depends. So if you go for a linear regression problem, and then you have a pretty clear picture regarding the relationship between two variables, right? But if you go with deep neural networks, then definitely that picture is a little bit fuzzy, because you do not understand how networks are going to interact with each other. Rather, explainability depends on how much interpretation, how much explanation you can provide from the outcomes of the predictions. So it is much more the post hoc explanations. For example, your model is doing a prediction, then what are the features on that basis the model is doing the prediction. And interpretation, on the other hand, depends on how much complex models you are choosing. So if you are going for decision tree analysis, then definitely you can say a visible interpretation in that way. If you're going to regression, then there is a lot more interpretation that could possible, because you know the intrinsic function of the models. Also, explainable AI plays a pivotal role in complying with the regulatory frameworks like GDPR, which mandates the right to explanation for automated decisions. So all these explanations that has to be provided is not because it is your decision to do. It is your responsibility to actually provide that intrinsic explanations, and to actually think about that whatever automated decision making you are trying to put into your business, how much fair explanation you can provide towards that as well. So these are some of the very intrinsic factors that we need to keep in mind when we talk about responsible AI and explainability, because they are very highly correlated. And if you can achieve maximum uh, explainability, then definitely there is a path forward where you can deal with biases, transparency, interpretation, and all these aspects of responsible AI. This graph, which is presented here, is actually between accuracy and interpretation and explanations. So it suggests that, so the source is also mentioned here. If you want to read a very technical plus fill with examples, so this book is really good. I will suggest anybody who is much more interested into this field, they should actually refer this book. And this detailed that the more you go with accuracy in your mind, so it is very, it's a very difficult and complex situation as a data scientist or as a data engineer, when we try to design AI systems that are highly accurate and highly explainable. Now, that is one area where I'm always asked the question that, ma'am, what should be the approach? So now that is a way, there is no right answer to it, because there is no one particular model where you can say that, okay, this is the model where you will get maximum accuracy, and this is the model which will give you maximum explainability. Rather, it is actually the opposite ends of one graph. So, for example, the more complex you go with your algorithms, the more high accuracy you will achieve. So, as I said, that if you go with deep neural networks, the accuracy will be the accuracy will be very efficient. You will get great accuracies. You will get much more wise, model predictions, much more scalable model predictions. But at the same point of time, if we talk about explainability, then the actually the level of explainability that could be applied to deep neural networks is limited. So you cannot expect a deep neural network to be fully and intrinsically explainable, because you do not understand the way the hidden layers of these deep neural networks are actually trading off information. So that kind of understanding also builds with experience. So every time there is a problem which is faced, I always suggest that go with the simplest solution as far as possible. So for example, if you go with simpler statistical models like linear regression, decision trees, random forests, now these models actually do not have the capacity to provide you much higher efficiencies, but at the same point of time they are much more explainable. So you are actually trying to, if your agenda is that you want something, and you are actually creating an AI system where both the ends are very critical, and you want to design a system which is highly explainable, then definitely you should go with much more simpler statistical models where the explainability could be reached maximally. Rather, if you go with much more higher versions and complex algorithm, then the trade-off trade-off between explainability and accuracy comes into the picture. And now that depends on the experience of of the data scientist or the machine learning scientist who are working on the project, that how much trade-off they can compromise. So what is the level of trade-off between accuracy and explainability that you can compromise and you can actually bear with your models? And there is a very famous example for explainable AI and accuracy, that there was a team in UK, and there was a team of radiologists in UK, and they were actually designing a system from chest X-rays, and they wanted to predict the disease using the pictures of chest X-rays. And they invested huge money and resources into building a much more capable system. And the system was highly complex in algorithm. They were actually using deep neural network, and the model was performing very well on training data set. And when they tested on test data set, the model was again giving high accuracies. And when they were actually using on validation data set, the model was again very efficient when they were using it. But the moment they try to actually deploy that model on real data set, on real patient scans, and those chest x-rays, the model was not able to give the prediction. And imagine that these kind of models and these kind of research outcomes are not, they are not short time period projects. Rather, they scientists invest huge resources into these kind of models and preparing these kind of experiments. And after that, when the model was not working, it actually created a lot of anxiety among the scientists and the team, that why the model is not actually behaving as it was predicted to behave efficiently on real data set. And after much more discussion around, and many more actually night suffering to understand that why the model is not actually behaving the same manner, they decided that they came along that let's actually leverage explainable AI to understand that how the model is working. Let's begin it to understand the how the model is doing the prediction, and then maybe we can come up with some kind of debug intervention, and maybe we understand that why the model is not behaving accurately. And when they did that, they actually identify that the training data set that they were feeding into the model have very small peculiar pen dots. So what was the problem was that the radiologist use a pen to actually mark that spot into chest x-ray where the problem lies, and on which they do the prediction that okay, this may be the problem. And it was very small to the naked eye, and they were actually it get ignored when they were doing the training and the cleaning of the data set. But via leveraging explainable AI libraries, they were able to understand that the model is actually learning from those dots. And on the actual data set, when they were actually deploying that model on actual chest x-rays, the model was not predicting because the pen dots were not present on the actual data set. And then they just reestablish, and then they just figure out that okay, we need to change the training data set, and then apparently the model was working at the end. So this is the power of explainable AI, and this is the power where you need to understand that what you are designing, you need to understand that why you are designing, you need to understand that how it is working, rather just only focusing on that okay, there is a high accuracy demand that I need my model to work around 96 or 97%. And if that is the focus, then it becomes very difficult for both the users and the people who are building and designing these systems, because most of the time they are multidisciplinary systems and multidisciplinary people who are actually working on these projects. So you may have data scientists, you may have engineers, you may have field experts, like in this case clinicians and practitioners. And when they do come along and they work, then it becomes very difficult to understand that what is wrong and what gone wrong in the whole process. So explainability, if you keep intact explainability very close to your designing part from the very first step, then it becomes fairly easy to you to debug your system as well, because you know that how the model is actually performing the predictions. Next, we will discuss is that when clarity compromises privacy and challenges in AI development. Now, the other aspect of this is, and the question that you will also have in mind is that what if whenever we try to put explainability into the picture of AI systems, what if they actually we compromise the privacy of the customer in the data set. So, for example, in this case, the data set was chest X-rays, so there was no issue. But imagine that if I will leverage this into a data set of customers. Now, in that data set, maybe some features are so some features may lie to the privacy of customers. So if I'm actually leveraging explainable AI to the outcome of a model, and if I'm seeing what are the features that are dependent on such and such outcome, and those features may belong to very private information, for example, maybe the gender, maybe the other details, maybe the marital status and all these variables and features may be personal to some customers, and they do not want to share for any kind of, or they do not consider it comfortable to be used. And now this is also an area which is actually evolving very rapidly, that how to ensure that trade-off between privacy and clarity. So for example, the explainable AI libraries are now getting sophisticated. So we are trying to imagine the outcomes of these libraries where the privacy is not compromised of the customers, or the features that these libraries are leveraged on. Then we are making sure that okay, those features are not giving the details. If any feature is there who is that feature belong to that privacy protocol, then definitely that feature should not be shown to the explainable AI part. So these kind of trade-off between transparency, confidentiality, model interpretability techniques, and data leakage, debugging and auditing AI models, and trade-off in federated learning and distribution system is something which is a very evolving field where I'm also working. Specifically, we talk about federated learning architectures and distributed systems. So these systems gives you a high level of privacy, but at the same point of time, it is highly probable that the security and the if it comes to the explainability part, then definitely the systems that are sharing, different clients data set, and let's say the model output, the when the model outcome is coming, and whenever you are trying to apply the explainable AI practices towards the model outcomes, the possibility is that definitely some client information may get leaked from that part. So these kind of, the encryption, how efficient we can do the encryption from the very first beginning part of the data set training, and very first part of data prepping for the training of these models. So these kind of practices are getting, intact, to make sure that whatever we are designing and whatever system that we are building to ensure one aspect of responsible AI. Let's say if I am assuring that, okay, I'm going to actually protect the privacy part using federated learning architectures, then how much assure I am that the security and the other explainability part is also not compromised. Rather, there has to be a balance between these three. So all these parameters that we are discussing, let's say the transparency and the confidentiality, then we have to make sure that whatever techniques we are using and whatever disciplinary team we are, even it can be reduced when we give restricted actually access to all these applications and all these practices. So whenever we are designing a system and whenever we are designing a framework where we want to implement a AI system from the very first end to the very end part of it, then we need to make sure that what are the accessibility points and what are the human AI interaction we are keeping in feedback loop, and also what are the authorities, and how much they are actually allowed to enter the AI systems, and how much explainability they can demand from the systems. So these kind of distribution aspects can also ensure that the privacy and the clarity are not compromised at the same point of time. But definitely, these are the challenges that a lot of researchers and a lot of people are working continuously to make sure that, okay, what is that level where we can reach and where we do not compromise these two aspects of it. Next part, which is harmonizing AI explainability and data protection, which are the current best practices that we have, and the people are researching about, and the application are also we are seeing. So one technology is, or one methodology is differential privacy, where we dedicatedly put noise into the data set, and then we make sure that when the outcome are generated, then they are, they are not noisy, but they do not. So this whole pipeline create a secure a secure ecosystem where nobody from the external can actually see the original data, and the noisy data actually get leveraged by the model. But the part is that if I will share my recent experiment where I was testing with differential privacy on complaint classification models and the textual data set. Now, the problem is that whenever you actually apply differential privacy and all these methodologies, the accuracy drops down very significantly. So imagine you have a system where, the system is actually giving you 96% or 97% accuracy. And if you try to leverage differential privacy as one of the method to actually ensure privacy, then definitely your accuracy is going to drop down to 85 or maybe 70. In some cases, you may see a drop significantly up to 60 and, 50%, because the amount of noise and and you have to test it again and again. So you have to test that what is that particular balance of noise that could be added to these data set, so that you also not compromise accuracy, and also you make sure that the privacy is also intact into this process. Next is federated learning. Federated learning is emerging as a rapid field because, one, it provides a very strong architectural ecosystem for data privacy, and it gives the ability for different organization to leverage a model capability by not sharing their data, but sharing the model commonly. So federated learning architecture is very much applicable in future, because we are seeing a future where, a lot of organization have to collate to actually build one significantly efficient model capability. So for example, if we talk about complaint classification, and if we see that, okay, is it possible that we are moving towards a future where different financial organization can share one particular model, and that model can come to every clientele, and then it can train on those particular client data, and then they can perform efficiently for complaint classification, and which is beneficial for all the stakeholders that are actually leveraging federated learning architectures. Now, that is something that these kind of solutions are getting a lot of attention from the organizations and from the research perspective as well, because first, that it leverage resource optimization. Second, that it also makes sure a very important aspect, which is privacy and security. Other than that, federated learning are still in discussion regarding that how much secure connections we can build among these clients, and other than that, that how much explainability could be embedded into the FL architectures, and at what point of time would you like to to actually embed explainability. So for example, do the particular clients actually demand that kind of explainability from their end? So if we're talking about that kind of explainability, then definitely each clientele will be responsible for that part. Or do we actually expect a global explanation, or do we expect a global interpretation of these models? So for example, the model which is working inherently, do we expect that kind of explanation from every outcome the model is doing? So
Yeah,
these kind of discussions.
hey, honey, I'm back on stage. This is Clara. I'm just breaking in here a little bit. We're a little bit over
Okay.
time.
Yeah,
So
yeah,
I
yeah.
wonder, we unfortunately, we need to stay strictly to our schedule, but I would be remiss if I didn't give
Yeah,
you
yeah.
just an opportunity. If there's some final words that you want to share with us before we end this session, I want to give you an opportunity to do so.
Oh, I apologize because actually my screen was not visible and could not see you. But at the end, I think the key takeaway is that we need to just ensure and leverage the fact with our learnings, that how we can embed explainability, privacy, and the accuracy part. We need to play with these three dices all along. So yeah, that is one thing that should be the key takeaway of today's presentation. And I'm open to for any kind of question. They can question me, they can ask me in the chat box, or they can further put me into LinkedIn. Yeah, thank you so much for the time, and apologies for actually overtime. Yeah.
Absolutely. Such a pleasure to have you. I have many questions myself. I kept thinking about, well, how do we do this with children and parents? And so I will be chatting with you on LinkedIn, and I encourage all of our audience members to link up with Hani Yadav on LinkedIn as well, so you can continue this conversation. Thank you again, Hani. I really appreciate it. We will be back with the Responsible AI Summit in about 6 minutes with our next speaker. Thank you.